here now is what is called in the book hydrolysis of the salt. And it still means the same thing it meant up here. We're always reacting things with water. And in the older version of the book, I said he used to call it the hydrolysis constant. Now we use this relationship. And if we give you a salt like this came from what? NH4 plus. That come from NH3, the weak base. This came from HCl, strong acid. So this is going to be a weak base, strong acid sort of situation right here. And so we're going to have pH of less than 7. And we just have to calculate it. And the trick is, and hardly anybody, few people did this, but then didn't even use it, you have to calculate the K sub A. And I said that's the big difference with these things, that they don't give you the K for the substance, they give you the K for the either the weak base in this case, or if it happens to be something like sodium acetate, then you'd see Ka given, referring to the acetic acid part of this. And again, you have to use that relationship to get Kb to do the actual problem. And here it is, NH4 plus. The chloride is a very weak base, I guess, so it's not going to do anything. So it's the NH4 plus is a stronger acid, makes hydrogen ion ammonia. And then we're using the usual x squared over C0 minus x. The only big difference is you have to have the right K. Then you go through it, and for this one, the x is the hydrogen ion because there's the equilibrium expression. And one of the things I said is, when we're doing weak acids, which we haven't done for a while by itself, this problem, we sort of get in the habit of not writing down the chemistry of what's happening because it's always the same chemistry. And eventually we get to situations where you may have to think about writing the reaction so you can start filling in the IC table. I always call it IC because the E is sort of trivial, you just combine these things. But there's nothing wrong with writing, I just save a little time. Okay. And then I started talking about the titration curves, and I said, with all of these types of problems, you have to look at the chemicals you're given to decide what type of problem you're doing. Then when I talked about the titration curves, equivalence point, I said in here you're always doing a buffer. I did a polyprotic one here. I said we're not going to do this year. Here we're talking about simple. So I said whenever we do a titration curve, we don't have to think about what the chemicals in the system are. We just know that those are the different types of calculations. And I said that's the one type of problem I give you where you should recognize and say what type of calculation you're going to do right away.